In this video, we make progress to the sampling distribution of the sample proportion. To motivate this idea, we take the first example. Here we're told that a sample of 500 nursing applications included 60 from men. Find the sample proportion of men who applied to the program. This is the beginning of how we begin to understand what the sample proportion is. I usually prefer to just tell students proportion simply means a fraction or a part of a whole. So, out of the whole quantity of 500 nursing applications here, we have 60 from men. What is the sample fraction of men who filed an application to the program? In other words, the sample proportion, that is in statistics, or fraction in everyday English. These will be represented by P with a hat. So this is pronounced P hat. And it represents the fraction of those items or units in a sample who meet a certain characteristic of interest. In this example, it will be out of all 500, how many of them were men, were applications from men? That was 60. So 60 out of 500, that is 0.12, same as 12%. Take note that there is a general formula we can derive from here. That is, the general impression here is that the sample proportion is out of the sample size, the total sample, how many satisfy that characteristic that they are men who apply to the program. That will be X. This particular formula is called the formula for the sample proportion P hat. As much as it can be defined for a sample which is a part of a population, so can we define it for the entire population if we are able to access the entire population. However, in reality, we know that the entire population may not be accessible, and so usually we estimate the population proportion using the sample proportion, hence this formula. So let's see, what is the distribution of this sample proportion? Under certain conditions, we will find that it also has the normal distribution, which is why the normal distribution is one of the most important distributions used to approximate many distributions. First of all, as long as the samples we are selecting are simple random samples and the conditions for a binomial distribution are met, and in particular, the sample size is less than or equal to 5% of the entire finite population, and NP times 1 minus P is at least equal to 10, we can say that the distribution of your P hat can follow approximately the normal distribution, which means we'll need a measure of center, the mean, and we'll need a measure of spread, the standard error. More on that in a little bit. Let's move on to the next page. This is a formal definition of the reality or of the distribution of the sample proportions. In particular, without wasting your time, as long as these highlighted conditions are met, the sample size is less than or equal to 5% of the entire population, and N, the sample size times the population proportion times 1 minus the population proportion is at least 10, we can use the normal distribution. So as long as those two conditions are met, we can use the normal distribution to approximate the sampling distribution of the sample proportion. Enough of those statistical jargons. Let's get into the gist of the matter. So we look at this example. Suppose a simple random sample of size n equals 150 is obtained from a population whose size is 25,000. So this is the population size, and this is the sample size. So 150 was drawn randomly from 25,000. And the population proportion has the value P equals 0.4. Take note, this is population proportion. Proportion. Question A, we're to describe the sampling distribution of P at. I'm going to split this into two. What you first want to do is to check a couple of conditions first. You have to check this first condition and this second condition. That is, one, what is my n? My lowercase n, the sample size, is 150. Then what is 0.05 times the population size? 0.05 is 5% of the population. That would be 0.05 times 25,000. This would give 1250. Well, what do we observe? We observe immediately that the sample size is less than 1250. That is very, very good because that meets that condition that should be lesser than. The second condition is to check the value of n times p times 1 minus p. Calculate it, then check if it is greater than 10. Let's go ahead. N times p times 1 minus p. Our n is 150. Our p is 0.4. Then 1 minus 0.4, which is the last part right here, is equal to 0.6. And that is equal to 36 by my calculations. That is greater than 10, which means it meets the second condition. Once it meets both conditions, we'll learn that a normal distribution can be used to approximate the sampling distribution of the sample proportions. So that means that I can now describe the sampling distribution in terms of its shape. So A, the shape would be the shape of the normal distribution. And the shape of the normal distribution. I can find the mean using this formula. So B, the mean of all the sample means will be the population mean, which is 0.4 directly, no calculations necessary. Question C, then the standard deviation of P at. So standard deviation of P at, that is this, is equal to the square root of P 1 minus P all over N. This will be equal to 0.4, 0.6 divided by N. N again is 150, and that gives you 0.04. With this said, I can proceed to part B. We are to find the probability, capital P, of obtaining x equals 63 or more individuals out of 163. So the probability that the sample proportion is 63 out of the sampled 150. That is equivalent to probability that the sample proportion is greater than or equal to 63 divided by 150 is 0.42. And since we are using the normal distribution, that makes our lives so much easier, which means we can use StatCrunch. So let's see. I'm going to put the mean. What is the mean in this case? The mean is 0.4 in the middle, and the standard error is 0.04. So standard error is 0.04. And in particular, in this question, I'm interested in probabilities connected with 0.42, and we are looking at greater than or equal to 0.42. So this is equal to, let's see, we're going to go back to StatCrunch. So going back to StatCrunch, I'm going to need the mean in blue and then the standard error. The mean is 0.4, Standard error is 0.04. So in StatCrunch, I have those values here, the mean and the standard error. Then in particular for this question, we want greater than or equal to 0.42. So I will change this to greater than or equal to 0.42 and compute. The answer here is 0.3085. That is my final answer there, 0.3085. Then for question C, what is the probability of obtaining x equals 54 or fewer individuals? So probability, the P hat is less than or equal to 54 out of 50. This is same thing as probability that the sample proportion is less than or equal to 54 divided by 150 is 0.36. So using, again, the normal distribution that makes our life a lot easier, still have 0.04 here. And in connection with 0.36, we want the area below, to the left. So I'm going below. Okay, so what is the size of that area? Here we call on StatCrunch. So I go back to StatCrunch, change this to less than or equal to 0.36 and enter. So you have 0.1587. 0.1587. This is the required probability there. We now proceed to the next example. In this example, we are told that according to a survey in a country, 22% of adults do not own a credit card. So this is in the entire country. So this is a population proportion. Take note that the population proportion does not have any hat on top of it. It is the sample proportion that has the hat, which indicates that it's an estimate. So suppose a simple random sample of 300 adults is obtained. So in this case, we are to compute or complete parts A through D below. In part A, we are to describe the sampling distribution of P hat, the sample proportion of adults who do not own a credit card. In order to see if we can use the normal distribution, we have to check our usual conditions. Condition 1 is to compare the sample size of 300 to 5% multiplied by the entire population. Well, in this case, we don't have the entire population size, but we know that 300 people, more likely than not, is definitely lesser than 5% of the entire population. So then for 2, we need to check n times p times 1 minus p. That will be n is 300, our p is 0.22, 1 minus p, 1 minus 0.22 is the same as 0.78, and that is equal to 52.48. This is also greater than 10. This is good. Both conditions are met. So for the shape, again, we can use the normal distribution. It will be approximated by the normal distribution. For the center, you have the mean of P hat, which is exactly equal to P, and that is 0.22. And then for the spread, we use the standard deviation, which is P 1 minus P all over N, or P is 0.22, 1 minus 0.22 is 0.78, divided by N is 300, the sample size. And this, when I did this, gave me 0.0239. So with this distribution, we're ready for question B. What is the probability that in a random sample of 300 adults, more than 25% do not own a credit card? So proportion that in this sample, the sample proportion is more than 25%. 25% is the same thing as 0.25. So using the information we gathered earlier, which means we can use the normal distribution. The mean of P hat is 0.22. The standard error is 0.0239. Based on this, we would like to compute the probability connected with 0.25 and above. So let's see. So I'll key in these parameters in StatCrunch. So let me do that.